Okay, some quick board work today. Um, I think the bounds will be a little bit easier, I hope, than the last problem we did on the last day we were together. Um, I air quoted that. All right, so the first one is evaluate the triple integral over b of x squared plus y squared plus z squared dv, where b is the unit ball. So that. So I'll let you should pause. You should be able to set up these bounds, do all the integration. Okay, here's my answer. This was like one of those everything things. Rho went from 0 to 1. I got 4 pi over 5. So let's go through how I did that. 0 to 2 pi on the thetas. That's because it's the unit ball. It's the whole thing, right? Phi goes 0 to pi, North Pole to South Pole. And then rho goes from 0 to 1 because it's the unit ball, right? I got rho squared here. That is the thing that I'm integrating. And then this is my volume element, all this. This gives me rho to the 4th, so I just integrated that and got 1/5 rho to the 5th, evaluated from 0 to 1 with a sine phi d phi. And I also did my 2 pi out front because there were no thetas in my integral. So this just, since I got a 1, it's simple. It gives me 2 pi over 5. And then I need to integrate sine phi d phi from 0 to 1. So I get negative cosine of phi, evaluated from 0 to pi. This seems to happen a lot. If I guess like anytime I have um, some thing that I'm integrating that does not involve a phi, then I'm gonna just wind up integrating this sine phi, and I get this double negative crazy stuff that just is really just a 2. So anyway, this is 2, which gives me 2 pi over 5. Sorry, 2 pi over 5 times 5. Sorry, 2 pi over 5 times 2, which is 4 pi over 5. Hopefully you're good with that. I got lots of time, so I think I'm just going to do the next one in this video here. So I will scroll down. Oops. All right, right there. Okay, so this one's a little bit more work. I think I can definitely do it in the amount of time that we have here. But I want you to evaluate the triple integral over r of x squared dv, where r is the region bounded by the xz plane. You should draw that to figure out what that is. Double check that you're doing it right. And the hemispheres, right? So half spheres, this thing and that thing. These are z squareds right here. It's x squared minus x squared minus z squared. So my advice for this is, let's see. 1, use a calculator for the arithmetic. 2, when I got to my answer at the end, I was like, there's no way this is correct. This number is so terrible. But it was right. So, yeah. So, pause, give it a shot. Okay, here comes our answer. Badoop, badoop, badoop. I got 1,562 pi over 15. You can see why I didn't think it was right. So I'll go through how I did that. This is x. I guess I didn't label y there. In our 3D space, x comes out here, y goes over there, z goes up, right? So I want you to see that I go from here out to there. Oh, sorry. So this is the xz plane right there. You can sort of see I sketched in that right there, but the scan didn't pick it up. But that means that I'm taking things that are over here that are to the right of that vertical plane right there. Well, that, if you think about your polar, and go back to your notes if you need to, but that's theta stretching from 0 out to pi. So that's where I get this bound. Phi is just everything because we're taking hemispheres, so I need to take North Pole to South Pole. And then rho, if I were to square both sides here, I would get, and pop these two over, I would get the equation of a sphere. So it is radius 3, square root of 9, and then the other one is radius 4. So rho actually goes from 3 to 4. Last thing I did was I was integrating x squared dv. So I had to look up, which is fine, what that x conversion was. It's like all open notes at this point for us, right? So I looked up, it was rho sine phi cosine theta. And then I just squared everything, right? So rho squared, sine squared, cosine squared was x squared for this thing. So come down here. And at this point, you're like, oh my God, right? But it works out okay. Everything's separable. It's this line here. But anyway, so look, this, I just wrote rho to the fourth because I knew it was going to get multiplied by the rho squared in the volume element. And then there's a sine phi in the volume element, so this sine squared popped to a sine cubed. Cosine squared stayed the same. So all these are separated by multiplication. This is not dependent on any of the other two variables. This is not dependent on the other two variables, etc. So I can fully separate this triple integral out into 3 smaller single integrals. You could do it without doing this. It's just, for me, it's a lot less writing this way. And I'm gonna kind of parallel do work for each of these pieces as I go down. This integral, this is part of where these terrible numbers come from, is the 4 and the 3. That goes up to rho to the 5th divided by 5. So I just did that. I did 1/5, 4 to the 5th minus 3 to the 5th, right? Type that in my calculator, and that gave me 781 over 10. All right, so this piece here, integral from 0 to pi, I used power reduction, and I did the, this is the thetas right here, right? Because I don't know, I was just thinking about spacing and stuff. You could do it in another order. 1/2, part of the power reduction, 1 plus cosine 2 theta. Whenever we do these power reductions, it works out pretty nicely in the sense that these guys usually go away, especially if we're integrating from 0 to pi or something like that. So, I get, when I integrate this with respect to theta, I put the half out front. This gave me a theta. This gave me a 1/2. This gave me a 1/2 sine 2 theta. Evaluate that from 0 to pi. I get this guy's my pi. Oh, so I took the half and I multiplied it by here. Oh, I'm sorry. So this was 781 over 5. This piece right here. So I put the 2 in there, I get 781 over 10. This stuff, I wrote the first two terms. This gave me a pi. This gave me a 0. And then both of these guys, when I plug in 0 are 0, so I'm minus 0. All right, so now let me talk about, all right, so that gives me 781 pi over 10. Let me talk about the rest of it now. This is a little throwback to like January, maybe. Man, January feels a long, long time ago. Anyway, throwback to January, maybe even December. Ooh, maybe even 2019. Whoa. All right, so anyway, sine cubed. How do I integrate it? Oh, I leave the sign there. I leave one of them, and then I use the what's that formula? Pythagorean identity, right? So I replace, this is sine cubed is really sine times sine squared, and sine squared is 1 minus cosine squared. And then from there, I did some scratch work down here. Let me zoom out a hair. All right, so u was cosine phi. I actually was trying to do this in my head, and I was like, nope, can't, right? So I had to do this scratch work. Some of you might be able to do that, not me. U is cosine phi. Du is negative sine phi. This negative is from the negative here on the du. because that's a positive sign, and here I got a negative sign. And then I got a 1 minus u squared. I distributed the negative in to get u squared minus 1. I guess I'm integrating that with, this is terrible notation, but there should be an integral sign and an integral sign. And then after I integrate that, I get 1/3 u cubed minus u. So then I plug that stuff in here, right? So that gave me 1/3 cosine cubed phi minus cosine phi. And then I had to evaluate that from 0 to 1. So I drew a little unit circle. Cosine of 0 is 1. Cosine of pi is -1. With all this stuff, I know that like all the numbers are simple, but I'm writing it all out because I don't want to mess it up. So I get 1/3 -1 cubed minus a negative. Why is it that? Because I've got this minus is that minus, and then this negative is that negative. Minus, and then these two evaluated at 0 are a little bit easier. This is just 1/3, and this is just 1, and that negative is this negative. Once again, I wrote it out again. This is -1/3 plus 1 minus 1/3 plus 1. And then I did some math in my head. I got 4/3. And then I took my calculator and I multiplied all this stuff. And I looked at this answer and I was like, no way is this correct. But then I checked it and it was. That's all for today. We will pick up again tomorrow. We might do some more practice. We might just bounce into the next thing we're going to do. So, hope y'all are well. Hope you're doing well with this, and I will talk to you soon.